Hello, everyone. This is Mr. Olson. I know you can't see my face, but I'm going to write some things on the whiteboard, which is what this is right here. I also want to show you guys the Petri dishes, hence why you just have a downwards image. So today in class, we actually gathered data from the bacteria lab that we've done yesterday and last week. So we played the different bacterias, we test them against antibiotics, and now you guys have a little bit of background about what an antibiotic does, how it kills bacteria, and you actually might have a little bit of knowledge about the bacteria that we played in. So today we're going to actually look at what the data looks like, how our students collected data, and this will lead us into our final, or not final project, but our project that'll be assigned on Friday. So let's get going with it. So over here, I have three different Petri dishes, which I'm going to show you. We have Petri dish A, we have Petri dish B, and we also have Petri dish C. Now, Petri dish A, which is right here, is going to be our Serratia. B will be our E. coli, and then C will be our Bacillus subtilis. Now, I'm going to kind of tilt these a couple times so you guys can kind of help you get a better angle of it. These ones, guys, have white bacteria or almost a cream-colored bacteria that you guys kind of can see. Now, Serratia, on the other hand, has a red bacteria, which makes it a lot more apparent and a lot easier for you guys to see on this white background. And then C looks something like this with also a white background. Now, today we're going to measure these, and we're going to measure something called the zone of inhibition. Now, the zone of inhibition, what that means is the area where bacteria doesn't grow. So, let's say this is our Petri dish. We have this broken down to quadrants, and we put antibiotics in all these little different sections, and we had our control in the middle. Now, assuming we did everything right, this whole Petri dish should be covered with bacteria. But as you're going to notice, is that I'm just going to focus on this one quadrant right here. The bacteria might have only grown here. Now, why didn't it grow in this clear spot? This clear spot right there is going to be called the zone of inhibition. Now, what this means is that that antibiotic actually killed the bacteria. That bacteria is not resistant to the antibiotic, so hence why it died, giving this thing a zone of inhibition. Now, in some cases, you might see something like this. Where the bacteria grows right over the antibiotic. Now, this means is that that antibiotic was not effective against that type of bacteria. So the bacteria had freedom to grow. Antibiotic didn't do anything, hence why it goes over the top. So today we're going to actually measure these, take some observations, and be able to do this. Now, we're not going to go through every last measurement. You guys are going to see some of the data on Friday, but I'm going to go over just a couple things with you so we can be all on the same page. Now, let me erase this quick. And let's start off by looking at a Serratia. Now, guys, I have to go grab a ruler quick, so give me one sec. Okay, got a ruler. Now, today, guys, we're going to measure everything in millimeters, and we're going to measure two separate diameters on our Petri dish. So I'm going to start here on number 1. So if I pick number 1 up, you guys should be able to clearly see that there's a zone of inhibition around our Petri dish. So this clear area is our zone of inhibition. Now, we're going to take two measurements, and the reason we're going to take two measurements is because then I'm able to average it out. But since we're going to take the diameter, it means I have to go all the way across. So I'm going to grab my ruler. I'm going to go all the way from there to there. I'm going to tilt it away from you guys quick so I can actually see it, which gives us a diameter in that angle of about 21 millimeters. Now, guys, I know it's opposite for you or upside down for you. I just want to be able to see it for myself. I'm then going to rotate the Petri dish. I'm going to take another diameter measurement from bacteria to bacteria, so where it starts until where it ends on the other side. And this is going to give me something right around 22 millimeters. So I'm going to take 22 millimeters. I'm going to add those up, divide by 2. This will actually give me 21.5 millimeters as my average. Okay, and that's what those students in class today did. So how this is going to work, we're going to end up doing those averages for zone of inhibition 1, 2, 3, and 4. Now, the idea is the averages here, when we compile all the data, we we should be able to see what antibiotic was the most efficient or most effective for Serratia, which one was the most effective for Bacillus, and then was also the most effective for E. coli. Now, the reason, guys, why this is important, because if you were a doctor and you had someone that had sickness, there's a bacterial sickness, it'd be beneficial for us to know what antibiotic we should give them that would be the most effective against that specific type of bacteria. Okay, so it's just kind of a cool way for us to show that. Now, there is some cases, guys, where it does not work. So I'm gonna can you guys see it on this side? You kind of can. Okay, so in the middle there's a control. And that control is just a paper disc with no antibiotic on it. It should have had bacteria grow all the way around it, which it did. So if this happens today, guys, they put a 0. And that 0 just represents that there is no zone of inhibition, and it means that nothing actually killed the bacteria. The bacteria is able to grow freely, giving you a number of 0. Now, today they did this for all 3 of these. I'm going to have a bunch of compiled data. That compiled data is going to be out on Friday for your project that will be assigned on that day. If you have any questions about how we did this today, please reach out to me and please ask. But all we did was take 2 measurements, average them, measure the zone of inhibitions for the A plates, for the B plates, C plates, and then also for the B plates. If you guys have any questions, please reach out to your teachers. Please reach out to somebody, ask. Other than that, guys, have a great day. We'll talk to you later.